two projects. In this video, we are going to explain about the project that is Social Media Forensics and Adaptive Cyberbullying Related Hate Speech Detection Approach based on neural networks with uncertainty. Before getting into the execution, first let us understand what is the project about. In today's digital age where technology is advancing rapidly, it is being increased rapidly, and here people using social media has also increased a lot. With this, cyberbullying is a problem that we are facing with. So with this increase in the social media, people being interacted more in the social media, cyberbullying has also become a major concern nowadays. So what is this cyberbullying? Let's understand this. Cyberbullying, it refers to the use of online platforms to harass, threaten, or embrace individuals. It can take many forms, such as spreading false rumors, sending abusive messages, posting hurtful content, or even stalking and impersonating someone. Unlike traditional bullying, cyberbullying can happen 24 by 7, and victims can be targeted by anyone from anywhere, making it even more harmful. The challenge in detecting cyberbullying lies in the nature of the language. It lies in the nature of the language used on the social media. Online communication is usually informal. It is usually informal, and people use slang, sarcasm, or even humor, which makes it difficult to understand their true intent. Additionally, there are cultural differences. So, because of those cultural differences and varying context, further complicates the identification process. So, social media forensics, they play an important role, which involves analyzing digital data to uncover evidence, which plays a crucial role in tracking and also investigating such incidents. However, due to subjective and ambiguous way people communicate online, detecting cyberbullying accurately remains a complex task. It is not just about identifying harmful content, it is about understanding the intent behind the words, which varies widely depending on who is involved and their context. So traditionally, we do have some techniques that were used for detecting this cyberbullying. So we had machine learning and fuzzy logic that have been used for detecting cyberbullying. But they often fall short because they can't effectively deal with the uncertainty and vagueness in the text people use online. So these models they oversimplify. This method tends to oversimplify complex relationship between words, which makes it hard to accurately identify cyberbullying content. The main issue is that language online can be very ambiguous. The people use sarcasm, slang, and informal expressions, which can be difficult for these systems to understand. This leads to misclassifications. So, this leads to misclassifications where innocent comments might be flagged as bullying or worse. Real bullying might be missed. So, this is why there is a need for more advanced and flexible approach, one that can handle the uncertainty and nuances of online communication and provide a more reliable way to detect the cyberbullying. So in this system, we are talking about the use of neural network. So in this project, we are incorporating multi-layer perceptron to overcome all the above challenges. This is great at learning from the data and finding patterns. To make things even better, it is combined with neurosophic logic, which is NL, that is neurosophic logic. Now, why this is important? Well, social media text is often full of uncertainty and ambiguity. People use a lot of slang, sarcasm, and vague expressions that are hard to interpret. This neurosophic logic helps thereby hereby adding a layer of flexibility, allowing the system to deal with truth, falsity, and indeterminacy in the language rather than just trying to classify something as simply true or false. As MLP in this project, this MLP uses one on one classification strategy to classify cyberbullying into different categories like age, gender, or ethnicity. This means it doesn't just say yes, this is bullying, but it even gives more specific information about what type of bullying it is. By combining the power of MLP and neurosophic logic, this system becomes much better at dealing with the gray areas in language and can more accurately detect and classify cyberbullying in social media content. Here, the system is trained on two key data sets to ensure it can effectively identify and classify different types of cyberbullying. The first dataset contains 47,000 tweets which are labeled across categories like gender bullying. So it is labeled across gender bullying, age bullying, age related bullying, and other forms of cyberbullying. This helps the model to understand specific patterns in these types of harassment. And the second data set, that is the largest data set, it includes total 1 lakh tweets and cover broader range of categories such as race, ethnicity, religion, gender, sexual orientation, etc. By using these diverse data sets, the system is not only able to recognize various forms of cyberbullying but also improve its ability to generalize across different types, supporting more accurate and fine grained classification. So here the system starts with data pre-processing. So initially we start with data pre-processing phase that removes irrelevant elements like emojis, stop words, and links to ensure the focus which is on essential content. And here we then use TF-IDF vectorizer. We use term frequency, inverse document frequency, that is nothing but TF-IDF, for feature extraction, converting the text into numerical vectors that the model can process it. And to address the issue of class imbalance, in this project we are using SMOTE, that is nothing but synthetic minority oversampling technique. It is employed to create synthetic data for underrepresented classes, ensuring the model learns from all the categories effectively. And all the models are evaluated using accuracy, precision, recall, and FN score. These are the metrics used to evaluate the models built in the project. By combining the learning capabilities of MLP with the flexibility of neurosophic logic, the system offers a robust method for detecting and mitigating harmful content on social media platforms. Moving on to the extension part, as a part of the extension, an ensemble method voting classifier is implied in this project. It is applied by combining the predictions of multiple models to enhance systems accuracy and robustness. This approach ensures that final prediction is more reliable by leveraging the strengths of different individual models. Additionally, topic modeling is also used as extension. It is employed to extract the most relevant words or topics from the text. This provides deeper insights into the key themes and underlying patterns of cyberbullying content, helping the model better understand and differentiate between forms of harmful behavior. And front end we have built using Flash framework. We have used Flash framework to build the front end for user testing, which includes user authentication too for secure access purpose. This will allow users for testing and ensures the system performance is continually refined and improved based on user interactions and security needs. Moving on to the implementation of the project. To implement this project, we have followed the steps in the flow of work. So the first step is importing the packages. First, we import all the necessary libraries and packages that are imported to support data processing, model building, and visualization. In the next step, the two cyberbullying datasets are loaded and analyzed to understand the structure and the features. Coming to data pre-processing, the dataset is cleaned by removing punctuations, mentions, null values, and also HTML tags to ensure a clean and usable dataset. Then the categorical labels are encoded into integers for compatibility with the machine learning models. Then this mode technique is applied to balance the dataset by generating synthetic data for underrepresented classes. Then TF-IDF and count vectorizer are used to convert text into numerical vectors, enabling the model to learn from the data. Then the visualization part comes in. Here, the dataset is visualized using Seaborn and Matplotlib to display the sample outcomes and generate a word cloud for insights. Then we select relevant features. So here relevant features are selected to improve the model performance and reduce the overfitting. Then we split the data into train and test, where training set is used to train the model and testing set is used to evaluate the model. Then we initiate the model. So the model architecture is designed focusing on cyberbullying detection using an appropriate algorithm. Then the algorithm that is designed will be trained on the training data set, learning the patterns of cyberbullying content. And the best performing model will be saved for later use in classifying the new inputs. Coming to the part of front end, Flash-based front end is created with user registration, login functionality, and SQLite database integration. Then the train model and tokenizer are integrated in the front end for prediction. In the front end, users they can input text via the front end for classification. And the input is tokenized, processed for prediction. And that will be fed with the train model. After the train model is used to predict whether the input text is cyberbullying or not. So here we will be feeding it with the train model. And then next, topic modeling is applied to extract the top words from the input text to gain deeper insights. Finally, the result insights are displayed to the user through the front end of the application. So this is how we have implemented the project. And here these are the algorithms used in this project. And this is the proposed model, that is MLP, multi-layer perceptron with 1 versus 1. This is nothing but neurosophic logic. Moving on, and this is the extension algorithm that is used to improve the accuracy, which is combined with boosted decision tree and bagging random forest. To implement this project, we need hardware and software requirements. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. This is the overview of the project. Now let us execute. To execute, we need to open the code folder which contains source code files. So let us open the code folder of the project. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? Here in the dataset 1 folder, we have the first dataset, that is cyberbullying tweets. So here we have total 47,600 change tweets. So these are the tweets used to train the model so that we will be able to detect cyberbullying, whether there is cyberbullying in the text or not. If it is, it will detect which type of cyberbullying it is. Now let's close this, get back. Let us open the second data set. This is a CB multi-labeled balanced data set. Let us open it. So these are the tweets in the second data set. Here we have different types of tweets and multi-classes. Let us close this. And this is a static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. And here we have templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And here we have the model files. So these are the model files which contain the algorithm information, and that will be loaded into the project code during runtime. And these are also the model files. These are also the model files. And here we have two notebook files. These are the two Jupyter notebook files that contain the code, graphs, and outputs all in one place. And it allows users to write and execute code in individual cells, making it a popular choice for the data science. So the first dataset one notebook file, in this file, first we will be loading the dataset one folder, dataset one, and then we will be training on that dataset so that we will be able to detect the cyberbullying in the dataset one. Similarly, in the dataset two. And here this is the sample file in which we have test cases that we will be using in the front end to detect the cyberbullying. And the last one we have is this signup.db file. This file is a database file which is used to store the user information. Now we have to execute. So copy the path of the code folder from the address bar of the file explorer. I've copied it. Now open the Anaconda prompt. Here it is open. Now give the command cd followed by the space, paste the copied path. Now click on enter. So here if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and now click on enter. By this, by giving this command, it Python script will be executed and runtime check will be run for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So here we got the local link. This is the local host and this is the port. Now copy this local link provided by the Flash framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. Let's register, click on that, and enter all the registration details if you are registering newly. To detect the cyberbullying, we need to sign up, and then only we will be able to detect the tweets, detect the cyberbullying. So now click on sign in, give your username. As we had already an account, so I'm directly signing in. Give your username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page of the project. As we're using two datasets in this project to detect cyberbullying. So first we will be doing cyberbullying for the dataset 1. So we will be doing cyberbullying using dataset 1. Click on that. Here you can see text box right here. We are supposed to give that tweet. For that, let's open the sample file. So let us open the sample file. So these are the test case of dataset 2, and here in this sheet we have test case of dataset 1. Let's try copying the first test case, paste it. This is the tweet that we are going to upload. Now click on predict. This given input will be pre-processed at the backend and then we will be getting the prediction. So this is the uploaded tweet. So we have uploaded this tweet and here we got the binary prediction. That means whether it is cyberbullying tweet or not, here it is. So the tweet is cyberbullying tweet. And which type of cyberbullying it is? Religion based cyberbullying tweet. So this is the tweet that we have uploaded. First it is classifying that it is a cyberbullying tweet. And in the next stage, it is classifying which type of cyberbullying. So it is classifying as religion based tweet. And here the topic for the paragraph is most dependent upon these words. So it is dependent on these words. Now let's try uploading some more tweets for the same data set. Let's try uploading this one. Paste a tweet here, click on predict. So here this we have uploaded and here it is classifying as the posted tweet is cyberbullying tweet. First it is classifying it is cyberbullying tweet and then it is classifying it as age related cyberbullying tweet. It is age related cyberbullying tweet. And here the topic for the paragraph is most dependent upon these words. Let's try giving some more tweets for the same data set. So now let us upload this tweet. Click on predict. And here we got the prediction. So this is the uploaded one. And here it is classifying it as non-cyberbullying tweet. As it is non-cyberbullying in multi-class also we have it as just non-cyberbullying tweet. And this is the topic for the paragraph which is most dependent upon. Now let's check with the one more class. Let's check with this class. This tweet, click on predict. So here we got the prediction that posted tweet is cyberbullying tweet and that is other type of cyberbullying tweet. Now let's check with this one. Copy it. Paste it. So here this is the uploaded cyberbullying and here we got the prediction is it is the cyberbullying tweet and it is the other type of cyberbullying tweet. So this is all about the data set one, how we are supposed to upload it and get the predictions. Now let's try with the data set 2. Open the data set 2 sheet. Let's try uploading the first tweet. Paste it. Now it is not copied. Just give me a minute. Let's copy it again. Paste it. This is the tweet that we're going to upload now. Click on predict. So this also will be pre-processed the backend and then we will be getting the prediction. So here it is classifying as it is cyberbullying tweet and it is gender or sexual related tweet it is. And the topic for the paragraph is most dependent upon these words. Now let's try giving some more cases. Now let's upload this one. Copy it, paste it. Now click on predict. Here we got the prediction. So it is the cyberbullying tweet. This is the uploaded one, and this is the cyberbullying, and it is ethnicity and race related tweet. It is the ethnicity and race related tweet, and the topic for the paragraph is most dependent upon these words. Now let's try with one more case. Let's try with this one. Paste it, click on predict. So here we got the prediction. It is the cyberbullying tweet. This the uploaded tweet is the cyberbullying tweet, and it is a gender and sexual related tweet. And the topic for the paragraph is most dependent upon these words. In this way, just by giving the tweets, you will be getting the prediction. Now let's check with the graphs. Click on dataset 1 under graph. And here this is the sample outcome graph. So this is the sample outcome graph of binary variable. So here on x-axis we have cyberbullying type, and on y-axis we have the count of that target class. This shows the distribution of the target class. Here if you observe, cyberbullying are high than the not cyberbullying. So that is why we have used smooth technique to balance this target class. And this is the word cloud. Here we have binary classification. So these are the algorithms used to train the binary classification. So that initially, when we have given the tweet, first we got the binary classification that right, whether it is cyberbullying or not. For that purpose, we have used these algorithms. So here on x-axis, we have accuracy score, and on y-axis, we have algorithm names. And this is the precision score, this is the recall score, and this is F1 score. And here, this is the multi-class classification. This is a sample outcome. Here on x-axis, we have different types of classes that we have predicted after predicting it as cyberbullying. So these are different classes, and y-axis we have count. And this is the accuracy comparison graph. These are the models trained for multi-class classification. And this is the precision, recall, and F1 score. Let's check with the data set 2. So this is the sample outcome graph. And here we have word cloud. This is accuracy graph for the binary classification, precision, recall, and F1 score. And here we have for multi-class classification. This is sample outcome of multi-class classification. And here we have accuracy, precision, recall, and F1 score. Now click on logout. In this way, just by uploading tweets to the application, it will detect whether it is cyberbullying or not in the initial stage. After detecting it as cyberbullying, then in the next stage, it will detect which type of cyberbullying it is. And then topic for the important points will be extracted. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.